You, Kayla. I'm going to get someone else to help us out. Jack, what do you remember about categorical versus quantitative?
Categorical is categories.
Okay, categories. What's quantitative?
Amount of something.
An amount of something. Literally, when we say quantitative, we mean quantities. And an amount of something is there's two things you can do to get an amount of something. Does anyone remember what it was? Measure or count, right? So don't forget, not all numbers are quantities, but if you are measuring or you're counting to get that thing, then that is quantitative. Now, one thing I do also want to clarify is, when we say quantitative, we mean the response is a number. Because if I were to ask, hey, how many people in this class have curly hair, I would count, wouldn't I? But what's the response going to be? Categorical, right? The response is what matters. Category versus, or curly hair versus not curly hair. So keep that in mind that when we talk about categorical, quantitative, it's about the response. You're always going to have numbers when it comes to statistics. All right, so Deshaun, what does it mean for a question to be statistical? So if there is variability, right? Yeah, so think that along that line, variable, but variability in the what again? Starts with an R. Responses. We got variability in the responses. If you ask a question that has variability in the responses, you got a statistical question. And statistical questions, those are interesting questions. Those are the questions that help us learn about and understand the real world. Now be careful, what word do you not want to include in a statistical question? Makes it a survey question.
Personal.
Your and you, right? Because if I say, hey Tyler, do you wear glasses? That's just about you, and that's a survey question to help me maybe answer how many people at Hillcrest wear glasses. So be careful. Now, the word you can be used as long as there is a chance of variability in responses. Hey Tyler, how often do you get to school on time? Is there a chance for variability in those responses? Yeah, right? So those are things to keep in mind, but as a general rule of thumb, we don't want to use. Alright, so I'm going to move through some of these a little bit quicker, focusing just on the target sample. Actually, let's start with population. What is population? It's everybody, right? It's all the individuals that I want to know about. Can I usually collect all the information or information from everybody? That's a hard no, right? So, Jakayla, I can't collect the information from everybody, so where do I collect that information from? Can't get it from everyone, so I got to get it from a subset, a part of that population. What's that called? It's on the board. You gotta know this one. Look near the word population.
Sample?
A what? What is it?
A sample?
A sample. I will point this out, especially for girls, and I just thought about this, we should recognize the word sample a lot of times, because let's be real, have we gone and bought cosmetics and got a sample of something before? Is that the entire lipstick or the entire thing of makeup? No, it's just a part of it, right? A sample is a small piece of it. Okay, so we use our sample to make a prediction about the population in respect to a characteristic of interest. Now, keep in mind, what's the difference between surveys and observational studies and an experiment? I ask that question every test and people still get it wrong. How are experiments different from surveys and observational studies? The treatments, right? Because what are those treatments going to do? And by the way, treatments go with what, Marcus? Experiments, okay? So we have treatments and experiments so that, Taj, we can answer what question or make what kind of inference? The treatments help us make what kind of inference in an experiment? I'm going to come back to you because I'm going to get us help. So we're using an experiment, we're using treatments in those experiments, but what are the two types of inferences we want to make? Don't tell me which one goes with which. What are the two types of inferences we want to make? Say again? We want cause and effect, or we want to make a prediction about the, starts with a P, population. Remember, the whole idea is that We want to take a sample and make a prediction about the population, or we want to make an inference about cause and effect. Which one's treatments and experiments? Do you remember? Not sure. Bree, do you remember? Experiments and treatments are all about what? Cause and effect, right? So remember, experiments, so yeah, guys, these are all the ideas that we spent a week and a half exploring, making sense out of. We got to make sure that we're studying and practicing these things and going back over it. These are not unique, these are definition kind of things, right? And I'm going over these to help us recap. And there's a quick recap, but if you want to go back and watch this recap, I'm recording so you get this information, right? But an experiment's all about cause and effect, whereas surveys and observational studies are just trying to take a sample and make an inference, a prediction about the population, right? Okay, so remember, if our sample is bad though, that's called bias. Bad samples make bad predictions about the population. So we do not want bias. And what's the thing that we always have to have in order to reduce that bias? Well, we're always going to have variability, but I want to reduce the bias. Like, I want to make sure my sample represents the population. So I need what? Random sampling, right? Randomization. So remember, these are all those ideas. Only that randomization will reduce the effects of bias. Pay attention to those other types of samples and the types of bias we talked about in class. 1B, I'm going to move quicker through these because we already talked about them a little bit. Explanatory and response, right? The response is dependent. That's what the researcher measures. Explanatory is independent. That's what the researcher changes. What do we mean by experimental units? That's where the treatments go, right? That's what the individuals that get those treatments. And then the treatments, remember, those are just the values of the explanatory variable. Still trying to determine if it's survey, observational study, or experiment. It's all about those treatments. By the way, I didn't say it earlier, what's the difference between a survey and an observational study? What makes a survey a survey? You're asking individuals questions, right? Whereas an observational, you're only observing, you're not asking questions, you're not applying treatments, all those things. All right, so bias was the issue in surveys and observational studies. What's the issue in experiments? What's the issue in experiments? What can prevent good inferences about cause and effect? Not in experiments. Remember, bias is when our sample doesn't look like the population. That's observational studies. What prevents good cause and effect inferences? Confounding. When there's another variable that's also related to the explanatory and response that I'm not worried about, or I don't want to know about, that's confounding. And so that's where we have to use random assignment, always randomization, replication, and control to reduce the effects of those confounding things. All right, 1C. So, what's another word for mean?
Average.
Average, right? So when we say mean, we mean average. And what do we mean by, and so when we say mean or average, we mean what is typical, what we'd expect to see. What do we mean by standard deviation?
What differs?
Okay, so deviation literally means differing or deviating from. And standard also means that idea of typical. So it's a typical amount the data changes or differs from what?
The mean.
Well, not from the population, from the mean, right? The whole idea is how much that number typically deviates from the mean. Okay, so I think we need to maybe include that in some of the practice so that we get some practice with that. But we're about to look at the rest of these ideas of the target. We defined normal distribution already. It has to be symmetric and it has to be unimodal. Quick question. Would a distribution that looks like this, would that be normal? Say again. No? Thinking no? Anybody want to put, you're thinking yes? Why are you thinking yes, Deshaun? You're right, it is unimodal and symmetric, okay. Anybody have evidence for why no? Because Mason, you were originally thinking no, right? Yes you were, don't lie to me. We all heard it. Hey, let me ask you all this. What rule do normal distributions follow?
Empirical.
Is this going to follow an empirical rule?
No.
Remember, to be normal, it's not just symmetrical and unimodal, it's also, we call this bell-shaped, right? Just because it's unimodal and symmetrical doesn't automatically make it normal. The fact that it's bell-shaped, that it follows the empirical rule, makes it normal. So make sure you're paying attention to that detail. And then we're going to get some practice right now, finding percent of data between two values, calculating percentiles. One really quick thing, and so please add this into your note. So remember, we're not doing this one at all, so don't worry about that. But when I say the word probability, okay, so I just want to give this clarification. Actually, Ms. Kolsky, can you, I'm going to come back to that. Can you pull up the, you have the, let me just see that real quick. Okay. I'm going to clarify percent versus probability. I do want you to take some notes on this in a second. Okay, so yeah, mean is the average, standard deviation is a measure of how spread out our data is from the mean, so how much it typically differs from the mean. But we talked about this empirical rule, normal is symmetric and bell-shaped, right? So it follows that idea, empirical rule. Okay, so I want to point this out. As a reminder, do I have the, oh yeah, so what percent of data is within one one standard deviation? 68, within 2, and within 3. 99.7. So make sure you know that. So if you have a problem on an assessment, remember I'm going to want you to provide evidence for your answer, right? What's something really simple that you can do every time with the empirical rule and with normal distributions? It's right here. Draw and label a normal distribution, right? Can you show some calculations? And then put your answer with context. So, what percent of test takers scored at least 70 points? I got my normal distribution. What do I now need to do with this? Draw a line where? At what number? At 70, right? Like it's all about 70. And then I'm going to shade. Do I need to shade left or right? So it's 70 or less?
It's 70 or less.
Right, because it's 55 at least 70. Because I'm almost done, but I need us to get this recap so that we're ready to go to vertical surfaces. 100, is that at least 70? Yes. So I need to shade to the right. That's at least 70. Now remind me, which part of the empirical rule am I going to use? Write it out every time. The 68, the 95, or the 99.7? The 99.7? Why are you thinking that, Deshaun?
It goes all the way to the left.
Does it go all the way to the left?
To the right.
Notice, it actually goes past the, this is going to keep going, isn't it? It's going to go past that 3. But where does it stop over here? It said it stops at 2 standard deviations, which is dealing with 95. Now, be careful, because Deshaun, one of the things a lot of students like to do is they like to look at this right side and say it's half of 99.7, but does it stop at 3? So it's not half of 99.7, it's just half, or what percent?
95.
If I'm talking about just the right side,
50.
it's just half, so it is 50%. What's going to be on the left side here? Half of 95, right? So we're dealing with halves. So what percent of all test takers? 97.5, right? So 97.5% of all test takers score a 70 or better. And this is just to help us understand probability. If 97.5% of all test takers score a 70% or better, what's the probability that a random person scores a 70 or better? What's the probability that a random person scores a 70 or better? So that's the percent, though, of all test takers. One thing to be aware of, when we say probability, a probability has to be between 0 and 1. Say that one more time.
9.7.
90.7?
Yeah.
Likelihood or probability. How did I get this probability? I just converted it from a percent to a decimal. If 97.5% of all test takers score a 70 or better, well, there's a chance of 0.975 that someone scores a 70 or better. Okay, so that's all it is, and that's all I need you to recognize is that percent becomes the decimal version of that number, and that's it. Now, Lane, do you know why that decimal moves twice like that?
No.
No idea? Okay, so does anybody know, Jacayla, do you know why the decimal moves twice like that? How I got there? No? Tosh? So I need to explain that?
That's how you get that, like, percent.
Yes-ish.
You divide
I divided by 100. Anyone know why I divided by 100? So Deshaun's on to something. I need y'all to hold on to this. And so guys, please understand, when I do something, you're like, hey, how in the world did you do that? Ask that question. I only know to ask that question because I've seen students have trouble with that in the past, but like, Ms. Kowalski, you haven't done percents a whole lot with students, have you? So you wouldn't have known, right? Guys, ask that question so that we can help you. But I want to break this word down for you. Percent. What does that word per mean? It's a word that you said earlier, Deshaun. It was a word that started with a D.
So a lot of words
That's true. It was pretty recent though. What are you doing with that 100?
I'll divide it.
Oh yeah, so that word per literally just means divided by. How many years are in a century?
100.
That's a decade.
100.
100 years in a century. How many cents are in a dollar?
100.
100. Any guesses how many Roman soldiers were in a centurion?
100.
100, right, yeah. So when we see that cent right there, it's per or divided by what? 100. That's it. That's why that's happening. And so you'll have calculators on this test, on this assessment. If you just remember, hey, percent is divided by 100, that's it. A percent just means divided by 100. And so the probability is just the decimal version, okay? I am done putting some of y'all to sleep because we got to get some practice in before we demonstrate your understanding. So let's get here. I think we all got to at least D, like we completed C. So this is the check your understanding of the practice, and I need us getting to vertical surfaces. And Ms. Kowalski, you're gonna, sorry, I jumped ahead on you, my bad. Let's say 10 to 15 minutes, get as far as possible and talk. Mason, come on, we gotta wake up, we gotta get some practice in. Andriana, we gotta get up. You were just had your head up. Come on,
Up and at
let's go. I know it was a big review, but we apparently needed it.
Which one are we working on?
Wherever you stopped. And do you have the clicker?
I do.
Perfect. Can you go to slide, actually, I'm gonna start here. All right, guys, no, start with D, thank you. I need us to pay attention. I'm gonna go through this somewhat quickly because I've seen us working on this, but do stop me if you have a question. I cannot help if you don't ask these questions. Now, the starting point, we've got to remember, if I'm dealing with these normal distributions, there are things that we can do elsewhere, but for what we're doing, we're only using what rule for that normal distribution? Empirical rule, right? So if you see a normal distribution in my class, you should immediately think about what three numbers?
68, 95,
I'm not trying to trick you. Don't make it harder than that. We are dealing with 68%, 95%, 99.7. Now, remember, that's what percent of the data is what?
Between 8 and 12.
Between 8 and 12. So within 1 standard deviation. From 1 standard deviation below to 1 above, that's all of that data right there. 95% of the data is within
Two.
2 standard deviations, so from 6 to 14, and then 99.7 is within
Three.
3. Like that's it. Like if you know those, you gotta play around with those numbers until you find your answer. So when I look at what's below 12, okay, cool, I'm gonna mark 12, and I'm gonna mark what is below. Now, if you want to, and there are people who do this successfully, you can mark this in red, and what percent of my data is right here in the red? 68%, right? That is totally fair. You can do that. However, it's not necessarily the easiest, because then I still have to find this tail. But what can I do with this entire distribution? Split it in half, right? Like that's what I recommend. There's not the only way, but it's the way I recommend. So when I look at this, what's everything to the left of that mean? This left
50%.
half. How much?
50%.
50%, right? You're dealing with halves. Don't make it harder than that. Right here, I'm looking at one standard deviation, so I'm dealing with 68, 95, 99.7. 68, and how much is that 68? Half, right, of 68 is 34% for a total of 84% of individuals lie below 12. That would also mean I could call this the what percentile? So 12 is at the 84th percentile. Because that's what is below. Now, Aiden was getting a little frustrated with me earlier, and I get it, but I need us to pay attention to, first off, any questions on D. It's a game of halves. Okay? So, looking at E here, what I need us to recognize is, first off, we now have a percent, right? I don't have one of the numbers down here. I have a percent, so that's going to tie into one of these percents. Okay? It's got to. And when I look at this, I want what lies above that value. So just thinking about it, and one thing I do want to point out is, that's 0.15%, not 15%, 0.15. Just thinking logically, is that going to be 0.15% of my data? This is what lies above, right? Is that going to be 0.15% of my data? Which standard deviation do I probably need to go to so that I only have 0.15%? 30, or which one? 3 standard deviations, right? So remember, so this is what I want us to see out of this. When I look here from 4 all the way to 16, that's what percent? 99.7. So how much is in the tails over here? And those 2 tails is how much?
2.5.
Not this time. Remember, that's 99.7, right? How much do I have to get up to? What percent total? 0.3, but answer the question, I'm sorry, Dewan. What percent do I have to get up to? 100. I have to get up to 100%. Like the whole thing is 100%, is it not?
Yeah.
Okay, so what percent is total, not in one? If I need to get up to 100%, how much do I have in these 2 tails? 0. Not 1.5. It's 0.3%. Remember, I'm talking about both tails, right? And so outside of that 99.7 is 0.3%. But how many tails am I actually looking at?
2.
So I was looking at 2, but I only want how many of them?
1.
So 3 standard deviations above, or a value of 16. That's what it is. Like you need to know I'm still dealing with 68, 95, 99.7, but I am trying to find which value this time has 0.15% of the data above it. Okay? Trying to find which value has 0.15% of the data above it. And so I'm using that empirical rule. So, when I look at this one, I'm now dealing with 97.5%. So first off, hopefully we're recognizing, am I dealing with 3 standard deviations if I want 97.5%? No. Am I dealing with one standard deviation, the 68%, if I want to get to 97.5%? Probably dealing with what number of standard deviations? 2. Notice that's just logic. It's not memorizing things, it's thinking through. We know that that's pretty darn close to 95%. So let's check it. I want 6 or everything that is above, right? Alright, so someone remind me, what percent of data is between 6 and 14? That's 95%, right? Meaning how much is in my 2 tails? Both of them together? 5%, right? It's got to get up to 100%. So it's got 5%. But how many of those 2 tails do I want? Just one. So if I take 5%, split it in half, I get 2.5 plus 95 is 97.5. So what's the value? So I've got my percent. What's the value? 6. It's still going back to what rule, Aiden? What is it? What rule is it called? Empirical rule, right? 68, 95, 99.7% of my data lies within 1, 2, 3 standard deviations. That's it, guys. You're playing around with it. And here's the thing. Doing it the full way with all this math, like that's really strong evidence of understanding. But if you can just logically look at it and say, man, that 97.5% must be dealing with 2 standard deviations and 2 below, like if you can explain that, that's still evidence of understanding. Okay? Population of raccoons, yeah. Alright. I feel like we need to do this before we do the demonstrate understanding. So this is number 3. I added a detail into number 3. It was on the back side of what you've been working on. Wouldn't you agree, Ms. Kowalski, we need to do this? Alright, I think what I'm going to do is, and so be aware, like this is going to get funky. I'm trying to meet your needs so that you're ready for that test on Wednesday. We're going to do this problem. I'm going to start a bit of a review with y'all. Then we're going to do the study video that we talked about, start reviewing. And that means we're going to start tomorrow with this demonstrated understanding. And we're going to go immediately over it for you to take the notes that you need to take to improve your understanding. And Ms. Kowalski or I will make scans, hand it right back to you so you can use it to study for your test on Wednesday. Huh?
I just take it out.
No. No. Alright, so I need us to get up to our vertical surfaces. I need you to work on number 3. If you finish number 3, I don't want to see you standing around talking, chilling with people. I want you to work on number 4. And then we're going to do that extra little bit of review to start studying for that test.
I thought we were doing it.
You thought what?
We're doing these on vertical surface.
Everything but along.
Come on, Marcus. Michaela. Let's get up to that board. Let's talk. Let's learn.
This a little confusing.
It is a average, right? So the average what? I need context.
The average of population.
Well, the average about what? The average weight. Sorry, the average weight of the raccoons is what?
18.5
Something you're missing there.
pounds.
Pounds, right? Because we could be talking about kilograms, things like that. But the average weight of the raccoons is 18.5 pounds. And now I need the standard deviation.
4.5.
So you're just reporting a number, right? But when we say standard deviation, what do we really mean by standard deviation?
Typical change.
The typical change, right? So the raccoons' weights typically change or differ or deviate, right? Differ from what?
The mean.
From the mean. So from that 18.5 or from the mean by how much?
4.5.
That's it. Guys, it's just interpreting it, putting into context, right? The average weight is this much. The raccoon's weights typically differ from 18.5 pounds by 4.5 pounds. Okay? That's it. I need you to grab a seat, take quick notes while I set up the next part of today. Or the last part of today. It is time for you to get a watch. Oh.
That's
That
what
works too, I guess. Go ahead and pass it out. While I'm setting this up. Okay, so ladies and gentlemen, I need y'all to engage heavily in this video. Ms. Kowalski and I were talking about this, and I think that this video will be very informative for you, and I'm going to be cutting it close. But here's what I need you to do as we watch this video. I want you to think about study design, and what I mean by that is, one, what type of study is this? We'll continue working with this tomorrow, but what type of study? Two, what's my population / sample? What's my characteristic of interest? And if it's an experiment, what are the treatments and explanatory variables, response, etc.? So we're going to pick back up with this some tomorrow, but I want y'all to pay attention to this video. As you're watching this video, I want you to think about what type of study are we looking at here. Ms. Kolsky, can you hit the lights for me?
Yeah.
Okay, so by the way, just do notice, the question is, can we induce what? Did you notice it? Can we induce, notice not just helplessness, learned helplessness, okay? Okay? This is an important video, I want us to talk about it. This is why stats are beautiful and I love them. We also need to understand study design.
The biggest fear for an adolescent is written all the way throughout this text. The biggest fear of an adolescent, Jesse, not fitting in, is not fitting in. You talked about acceptance. Now to understand how this happens and how this looks and what this feels like, I'm going to have to do an activity. This is an on-your-own activity, and just this is not to tax you. These are easy things. This is just to kind of get you feeling what we're going to go over. So everybody, if you would take out a short piece of paper. I'm going to pass out these papers, and just keep them face down. And if you would, no one write on these, write on your own papers. Keep them face down. Yeah. Everybody have one? If you would, just do them one at a time, and I will tell you when to do it. Everybody turn it over. Just do your own work. And this isn't meant to be hard. These are anagrams. Just do the first one only. Go ahead and solve it. An anagram is rearrange the letters to form a word. Just one. Just rearrange those letters to form a word. When you're done, I need to see your hand raised. Okay, keep going. We'll wait. Keep your hands up, please. Just do number one. Don't go on. Don't go on. This isn't meant to be difficult. Okay, put your hands down. Let's just go to number two. Don't even worry about number one. Go to number two. Solve that one. Again, when you're done, I want to see your hands up. Everybody's hands down. We're going to go ahead and do number three. For number three, rearrange the letters, and as soon as you do, go ahead and put your hand up. need to know. You were both given two different lists. This side of the room was given these 3 words. And left side of the room, here you go. They were given bat. What would the word be? The second one, they were given lemon. Brian, the word? Melon. They were easy. The trick here was both of you were given the third word, which was the same. The third word was cinerama, which was American. Your first 2 words on this side of my classroom were not solvable. They were impossible tasks. I'm sorry. I know, but here's what we did this for. I was able to induce something called learned helplessness in the left side of the room very easily within about 5 minutes.
So really quickly, what type of study do you think this is? Experiment. How do we know this is an experiment? They were given 2 different treatments, right? The one group was given some kind of words, the other group was given another set of words. Now, there was not a lot to reduce confounding, anything like that, but I do want to point this out. And again, we're going to talk more about this to review tomorrow. After all of this study design stuff, before we move into, hey, hold on, pause for a second. Before we move into mathematics and the traditional math, I want you and I need you to reflect, because I feel like some of this in this room have not given ourselves a chance. There's a handful of us that are crushing it, engaging every single day. There's some of us that are putting our heads down and things like that. And I have to ask you, and I want you to think about it, is it that you can't do this class? Or is it that you have learned that you can't do math? Is it that you have, quote, learned that it's not important for you? Because in 5 minutes, she was able to induce learned helplessness in a whole side of her room. Even the students on the right-hand side who didn't get the word yet, they were still working. Whereas the left-hand side had given up. A handful of them looked at the question and got it. And I need you to understand, it is easy to learn to be helpless and to not try. And if you're there, I need us to unlearn that. Because all of you are capable. Everybody can find an anagram for tab and lemon, and it may take some effort, but cinerama. The students who believe that they could put in more effort. And because they put in more effort, more of them were successful. And so I need to challenge you, and I need y'all to hear me on this. Moving out of statistics, and we're going to continue talking about this as a review for tomorrow. Moving out of statistics, though, I need you to unlearn your helplessness. I need you to trust me. I need you to engage and use your resources and think and maybe even study a little bit. But every single one of you is capable. You're not helpless. And don't let yourself get into that mindset. You're capable of amazing things, and I need us to learn that for the rest of this semester. So if you come in my room and you're not sure what you're capable of that day, just tell me you're capable of amazing things. Tell me you're capable of learning something, because you are. All right? Ms. Kowalski, did you pass out the study guide papers yet? Okay, so I don't normally do a study guide, but I know we're rushing here at the end, so Ms. Kowalski passed out a study guide to help you study for this test that we have coming up. It has normal distribution stuff on there. It has study design questions on there. It has everything that you will see on your test on Wednesday. What are we doing to start tomorrow? DYU on normal distributions, on mean and standard deviation. We're going to immediately go over it. So we're probably going to be done with that in roughly the first 30 to 40 minutes. And then we're going to spend the rest of the day studying for that test.
Ed TPA forms, please.
Yes, get your Ed TPA forms in. I'm going to be messaging parents to help us remember. What's up, Sean? So remember, 16% is at or below, right? Okay, so when we say 16th percentile, is your
We'll do better tomorrow.
So do you think that 16th percentile is definitely less than 50th, right? Okay, so it's got to be a little less than that. Do you think it's going to be 1, 2, or 3 standard deviations that we're dealing with? This right now.
Oh, I see
Okay,
it.
think about this.
Thank
Think about
you.
this. If we have like 90,
It's not my day.
what percent is less than 2